so we're looking at square roots and cube roots, and we're looking at how that relates to indexes. So just to go over, square numbers are called square numbers because you can make a square out of that number of smaller squares. So I can make a large square out of 9 small squares like that. So there you go, and it's a square, and you know this. Multiplying a number by itself gives you a square number. So 2 times 2 is 4, 3 times 3 is 9. 4 and 9 will therefore be square numbers. So the square root of a number is the opposite. So it's the factor that when multiplied by itself gives you the square number. So if we say 8 and 8 is 64, the square root of 64 is 8. Okay, so it's the other way around. So in maths, we can write this as, let me move this thing over, we can say it's 8 squared is 64, and you can see the square root of 64. All right, so let's look at this. Square roots and indices. Now, this is really different, so I want you to listen. The square root is the inverse of squaring, which is the power of 2. So the square root is the opposite of doing something to the power of 2. So therefore, a square root is equivalent to an index of a half, right? So the power of a half. So therefore, if we did the square root of a, the index number that should be put there is a to the power of a half, okay? So that power is a half. It should be a little bit up there, okay? Just watch an example and it'll make sense. So they say to you, evaluate 16p. They want the square root of 16p to the power of 2. First thing you got to do is separate your variables. What are you looking at? So you're looking at 16, the square root of 16, and we're also looking at the square root of p2. Find the square root of 16. Now, what times what gives us 16? 4. 4 times 4 gives us 16, so we know it's 4. And replace the square root sign with brackets and the power of a half. So this is what it looks like. We go 4. So we've done the square root of 16 is 4 times by. We take away that square root sign, we put brackets in, and we put it to the power of a half. Okay? Use the fourth index law. Now, the fourth index law is p squared times the power of a half. So that will give you 2 times 2 will give you 2. 2 over 2 gives you 1. So therefore, you've got 4 times p to the power of 1. We just move this goodie away out of the way. Okay. And simplify that would be 4p. So your answer there is 4p. So what you're doing is you're separating them. You're giving it to the power of a half, getting rid of that square root and giving it to the power of a half. Timesing your powers, which gives you 1 in this instance, and you're simplifying. Okay. Now I want to show you another one, the cube root. The symbol, so it's a square root with a 3 on, means a cube root. A number that multiplies by itself 3 times to give the original number. So it would be 4 times 4 times 4 to give you a number. The cube root is the inverse, so the power of 3. Therefore, a cube root is equivalent to the index of 1/3. Okay, so the same thing, but now we've got 1/3. It's going to be the power of 1/3. Okay, so cube root of a is equal to a to the power of a third. So remember, this is up at the top, this little third thing. It's not next to it. Okay, so you get the cubed root of 8j to the power of 6. So same things, separate the variables. So we've got the cube root of 8, the cube root of j6. All right, so then we say, find the cube root of 8. So the cube root of 8 is 2, because 2 times 2 is 4, and 4 times 2 is 8. So we know it's 2. And then we will take this away, and we replace it with brackets to the power of a third. There you go. So we've got 2 brackets to the power of a third. Now we do our fourth index law, which means 6 times 1 is 6. Divided by 3 gives us 2. So now we've got 2 times, that's just explaining that. So we've got 2 times j to the power of 2, and then we simplify it, which would give you 2j squared. Will really be a good idea. Write these steps down, even go over the video again, and try it out.